This video is an example problem really to help you with the unit vector notation, the I hat and J hat, and might be getting frustrating for some of you, and that's fine. And I'm hoping that this example will help make things a little bit easier for you. So we've got a problem here. Suppose a particle moves with a velocity of v equals 15 I hat plus 10 J hat meters per second and undergoes an acceleration of a equals 1 hat I hat minus 3 J hat meters per second squared for 5 seconds. What will be the final velocity of the particle? There's actually two different ways to go about solving this problem. And I'm going to show you both methods. The first is using the unit vector notation, so using those I hats and J hats. And the second is breaking it into X and Y components and solving for things separately. If you've taken a physics class before, that second method is probably the most familiar to you. And if you use that, that's fine. Both ways are going to get you the right answer. So let's take a closer look at this problem then and how we can go about solving it. So for the unit vector notation, that's the method I'm going to use first. First, we need to ultimately figure out what we're trying to find. We're trying to find the final velocity. And we have what's given here, the initial velocity, and we also have acceleration and we have time. So the equation that we're going to use is final velocity is equal to initial velocity plus a times t. Okay? So that's really the formula that I need to get down to and use. And so in using vector notation, I'm going to do my v final equals, I'm going to take my initial velocity right here and put that into my formula, plus now my acceleration right here, and I'm going to substitute in my time of 5 seconds. And when I do that, first I'm just going to leave this initial velocity right here for the moment. And right here what I have is I have a scalar being multiplied by a vector. So I'm just going to distribute this to that vector. And that's how you can handle that. That's really easy. And now for vector notation, you're going to combine the like terms. So ultimately, I'm combining my I hats and I'm combining my J hats. So my final velocity will equal 15 plus 5, so 20 I hat, and 10 minus 15, so minus 5 J hat meters per second. And so that's how I can go about solving it using unit vector notation. So really simple, actually. But if you are someone who likes to use the X and Y components, let's also take a look at how we do it that way. So for this, I'm going to take my X and I'm going to take my Y and I'm going to keep them separate. Okay, I'm still using the same equation as before. I'm just using only the X components of things. And this is something I do when I teach physics for like a first year physics class. This is how we always approach these problems. So again, keeping things separate, but ultimately the same equation. And so now I'm just going to pull down my X things from my X components from up above. So for the velocity, the initial X velocity is 15 meters per second. And for the acceleration, it's 1 meter per second squared. Now time doesn't have a direction, so time is 5 seconds no matter what. And I find that for the X component of the velocity, the final X component of the velocity, it's 20 meters per second. Let's do the same thing over here with the Y. So my initial Y velocity is 10 meters per second. And then I have minus 3 meters per second squared for my y component of acceleration, and still the 5 seconds for time. And ultimately I get negative 5 meters per second. So you can see if I were to combine these two components back together into one final velocity, I would have 20 in the I direction minus 5 in the J direction meters per second. So both methods yield you the same answer. So you just pick which one works best for you, and good luck with your homework.